Okay, 2014, paper 2, question 9, parts A and B only. So we're going to go to a graph page, and we're going to type in the function that we've been given there at the moment for velocity. They've got it in terms of t, we're going to have to do it in terms of x here. So if I type 8, to get cos, press the trig button twice, and then press enter. We'll do 2 lots of x, subtract off, and we'll do control divide to get a nice fraction template. We'll pop a pi on top, 2 on the bottom, and then we're going to press enter. Now we need to just make sure that we're in either degree or radian mode, because we're about to do some differentiation integration, and we've got to be in radian mode. So if I press menu, settings, my graphing angle is indeed in radian, so that's good. So that's fine. And there's no restriction seemingly on values of x or t in this case, except we probably normally have positive values of t. So I'm just going to hold down the shift key to rescale the y-axis and just move our attention over here, because we're on positive values of t or x in this particular case. So we're going to find a formula for the acceleration. Now that will be the derivative of this. So what I can do is I can just go to F2, I could go to the template button, I could choose the derivative d by dx of, and I'll do variable f1 of x and press enter, and that red line that's turned up is the graph of the acceleration. Now they're looking for an algebraic expression for that, and they're obviously asking you to differentiate 8 lots of cos 2x minus pi by 2. And the way of checking to see whatever answer you come up with is we can graph it on top, and it should sit on top of the red graph that we have there. So if I was going to differentiate this, I multiply 8. Cos goes to negative sign, so multiplied by negative of sine. The bracket is going to remain unchanged, so that's 2x take away pi by 2. So control divide pi by 2. Oops, put the 2 in the wrong place. And then I've got to multiply by the inside function differentiated, so differentiate 2x and you get 2. So maybe simplifying this, I get negative 16 sine of the stuff. When I press enter, I'm hopefully that this is going to sit on top of the red graph, and yes it does. So there's a nice bit of visual check that I've done the correct algebra. Now being asked to find out whether the velocity of the object is increasing or decreasing when t is equal to 10. So somewhere along here t is equal to 10, and it's pretty hard to see what's going on. So what I'm going to do is I'm going to go to a calculator page, so control doc, and f1 was my very first function, so if I do f1 of 10, this is telling me what the velocity is at that time, but not whether it's increasing or decreasing. The increasing or decreasing will come from the second derivative. So if I do, the first derivative, which is in f2, and that's a negative answer. And so therefore it is decreasing. And remember f2, that was our one from using the template, and f3 was the one using the algebra we just defined, and this should give us exactly the same negative answer, but it doesn't. And the reason for that is something must be going wrong here. And the big difference is we were in a graphing page here, here we're in a calculator page, and we had to set it to be radians, so we've got to change these to be radians as well, and at the moment they're in degrees. So if I go to document settings, change this calculation page to be radians, and make that the default, and click OK. What I can now do is probably re-evaluate all of these, so that the speed when t is 10 is that. It's a positive answer, so it looks to be increasing, and this should give us exactly the same positive answer, and it does. So a word of warning there, whenever you're doing any trigonometry and you're switching between application pages, make sure that your calculator page or your graphing page is either in radians or in degrees for whatever it is you're doing. So, to conclude, 9 part B, the acceleration was positive, so the velocity was increasing. We're done.